Now from this video onwards, we are going to define the meaning of a series and we are going to discuss some properties related with that. So to start with, let's recall what do we mean by a sequence. Now simply a sequence is a ordered list and it is denoted like this. Say for example, if we have defined the an term as let's say 2 to the power n. So if we have our sequence like this, then we can even denote it like this. So the terms of this sequence will be equal to this is a curly bracket, 1 divided by 2, 1 divided by 2 to the power 2, 1 divided by 2 to the power 3, and likewise. Okay, and see here we are going to separate these terms with a comma in between, right? And a series means like the notation of a series is something like this. Okay, now see here also we are using kind of a sequence, but the thing is, instead of a comma in between the two numbers, we write like we have a addition symbol in between. So it's like we are adding up all these infinite terms. That's what we mean by a series. So to define a series, first of all, we need some sort of a sequence. See here, an is a sequence. That means an ordered list with a so when I say an ordered list, that means each and every term is separated by a comma. And for that particular sequence, if we use this notation, the sigma notation, then this whole thing becomes a series. And the meaning of this notation is we are using the same sequence, but we write a addition sign in between the two terms. So basically it's like we are adding up all the terms in our infinite sequence. Let's do another example. Say if we have this as our sequence, right? So now this is the nth term of the sequence, and if I have to express it in a correct way, then I have to write it like this. So this is the sequence notation, and that like a more illustrated form of this one is the list of elements. That is, starting from 1, we have 1 over 2, 1 over 3, 1 over 4, likewise. So the reason is, in my particular case, so in this second example, an is represented by 1 over n, and in the previous case an was represented by 1 over 2 to the power n, right? So this becomes the sequence. Now according to this one, if we write the sigma notation, then it becomes, now here also you have to indicate the starting point and the end point. Usually the end point is infinity. So then this becomes 1 plus 1 over 2 plus 1 over 3 plus likewise. See, the only difference we have here is you have a comma in between the terms when it comes to a sequence, and for a series you have an addition in between the two terms. Now instead of writing it as an, you can even write it as this one, right? Sigma of 1 over n. That will also give you the same idea. So here it says we should add all the 1 over n terms starting from 1 and goes up to infinity, right? Let's do another example. If we have n over n plus 1, now this, remember, all these are the sequences that we discussed before, right? So if we have this one, then we will start with 1 and goes up to infinity, right? 3 over 4, 4 over 5, and now we can even start the series from a different number like this. So in this case we have the same general format. I mean, the nth term is represented by this one, but here we should start at number 10. So n should be equal to 10 in the starting point, and then it will continue as before, right? Like this, 12 over 13, and likewise, right? So this is the normal way, or the basic idea of a series. It's also kind of a sequence, but you have an addition in between the terms, right? So in the next video we will define this addition in a more precise way.